So last time we started talking about pandas, and we didn't get too far because I wanted you to stop and I wanted you to go look at some of the code that we had done, and I hope you did that. And we're going to do the exact same thing today, where we're going to go over some more features, and then it will really benefit you is if you go look at some of this outside of class. And so this question of what is pandas, from our perspective, we're interested in this, the part that's in red, that it's multi-dimensional arrays with row and column labels and heterogeneous data types and robust support for missing data. So we talked about our primary interest in this class is in what we call rectangular data sets, for an obvious reason, that they could think of these as rectangular, where each row in our rectangle or in our grid here represents, think of it as an observation, and each column represents an attribute associated with that observation. And so we've seen samples of data sets like this. We did early on in class, we did a class or like a grade book where you had attributes of name and grade, or name and homework assignment and grade, and so on, where each row represented a student and each column represented one attribute of that student's grade. We've seen that in one of the videos that I assigned you was the SKU list example, where we did a more comprehensive example where we had SKUs and orders and things like that. And so we've seen examples of these rectangular data sets before. And so in pandas, what pandas support generally involves these three classes. You have series, you have data frames, and you have indices, which is the index type. So we went through some of these last time. And so what I want to do is I want to just sort of quickly go back over essentially the same structure that we did last time. And so again, let me initialize my my notebook. So I imported Numpy, I imported Pandas, and then I showed the two versions. And so back to our notion of deprecation, here's where you look at that version number. So here's Pandas version 1.05. And so if you execute this code and this number is prior to 0.02, then you are not going to get that deprecation warning that that we talked about in the Canvas discussion forum. So we have our show function, the same thing that we've seen many times before. So again, we have these three basic types of objects. We have something called a series object. So we just did a really simple invocation or creation of a series object that we named D1. And so what we did was we passed it a Python array, a Python list, and in our Python list, it is just a list of floating point values. And so the constructor for the Pandas series says, okay, I'm going to take that, that list, and I'm going to create a Pandas series. And a Pandas series has your data, and it has a corresponding index. And because we didn't specify the index, it used an index that's equivalent to the implicit Python index. So by implicit Python index, what I mean is it's zero-based integers for that index value. And then we looked at these types, and we looked at type of the D1, which is what we created as a series object. And we also noted that the data in Pandas objects, whether they're series objects or data frame, are stored as Numpy arrays. And that's why it's important for us to have an understanding of how Numpy works. And then finally, we have the index, which is a type of index. And so we talked about what this really means to have a series, to have a Pandas series, and we looked at two perspectives. We said a generalized Numpy array. So a generalized Numpy array basically says, okay, well, I'm going to treat my Pandas series as an array. And so in this case, I can do D23, and as expected, it gives me the value 1. And so if I look at this implicit index, if this were a Numpy array, this would be index 0, index 1, index 2, index 3. So it behaved exactly like we want. We also looked at slicing and said that in this case, when we did the slice, it also behaved exactly like a Numpy array, and that when I did 1 to 3, it started with index 1, went all the way up to, but didn't include index 3. So again, this is what we mean by a generalized Numpy array, or as a is a Numpy array. The generalized part comes from the fact that in addition to using the implicit indexing that we see in Python, I can also use the explicit index. So the index that I created in the second version was ABCD, as opposed to just defaulting to the integer index. And so I can also access exactly using that the index value. So just like we would in a Numpy array where I use the numerical index in a Numpy array, in a Pandas series, I can use the corresponding index value. And I can also slice. So I can also use the index values exactly like I would use the implicit index values that we saw in a Numpy array, as we see right here for B and C. But we made a note, and we will come back to this here in just a second, that in this case, element C is included. So here, element 3, the end element in my slice, is not included. But here, element C, which is the end element in this slice, it is included. And so that notion, or that using the implicit index versus the explicit index when you do slices, generates different behavior. We talked about that a good bit, and then I went through and did this other example where I have pets, and I use something that's not numerical as my index, but it's also not alpha, so it's not just ABCD, but it's just random values, how I ranked pets. So we talked about that a little bit. And then we also said that we can also view series as generalized Python dictionary. So this notion of a dictionary basically says I have a set of key values. And so in addition to viewing this as a Numpy array, I can also think of this as a generalized dictionary where I can access the values exactly like I would if this were a dictionary. So if I had a dictionary named population, then I would access it exactly this way. And so we can do that with the Pandas series also, okay? The generalized part, when we view it from the dictionary perspective, comes from the fact that I can also slice. So I can also, in addition to using the key value to find one value, I can also use that to do a slice. And so we did that, and then we saw the regular slicing, things like that. Then we created the second one and looked at those, and so talked about the fact that, hey, we have two different Pandas series, and if you look at these two Pandas series, and we know what the data is, right? So this is just not random text and numbers here. These are states in the United States and the population in the area. And so as we note, the two series both have the same index. My index is California, Texas, New York, Florida, Illinois, right? And so we can combine these into what's called a data frame. So that's the second primary component of Pandas. The first one is series. The second one is data frame. And with a data frame, you'll note that we have the index values, the same as we did with the series, but we also have an index for the column names. And so we see the states index here, California, Texas, New York, Florida, same as we saw before. But when we look at the columns, we also see that the columns are an index object type. So when we have a data frame, we have an index for the rows, we have an index for the columns, and then of course we have the values that comprise the data frame. Okay. And we talked basically about how to, extract things. We're going to talk more about this notion of extraction here today. But we said, okay, well, so what happens if I just use that index value from the column for the data frame? What it does is it just peels off that one column. And so if I want the other series, I can do that. I can just use its name. And then we looked at the corresponding types. And so finally, we then talked about, we created another index, and this time it's non-numeric. So we have the state color. So we use the same index and we have color. And so we created a series for that, and then we appended that to our states data frame. And so now our data frame has three columns: population, area, and color. We have the index column and we have the index row. And so now when we look at these values, we note that we no longer have all numerical values. We also have string values here. And so because the data are stored as a Numpy array, then we have to use the type object as opposed to what we previously had when we had somewhere up here, right here, we had type integer, because Pandas, when we created it, recognizes the fact that, hey, these are all numeric, so I'm just going to store it as a Numpy array of integer values, whereas down here, again, when you added this column, Pandas said, wait a second, I can't do that, so it upscale or upcast the type, the Pandas type, the Numpy type, sorry, for the data to object. But if we then go back and look at all of the individual columns, right, if I look at area, population, color, even though the overall values Numpy array is type object, the individual series types are the native types. So I have int64 for the area, int64 for
Welcome to Zoom. Enter your meeting ID followed by...
Wow. Hopefully that was someone in our group and not someone else who's just joining our meeting. Okay, so where was I? So we have the 3 columns in their native type. So we have int64, int64, and type object. Okay, and I'm pretty sure that's where we ended last time. We talked a really little bit about index objects, but I really kind of flew through there at the end and wanted to go back and revisit that. And so the index object, again, you can think of these. This is from the Vanderplots, and you should have a look at these other notebooks. So in this example, I've copied a lot of the stuff from the Vanderplots notebooks into our repository, but there's still a fair amount of information in those other notebooks that I reference in the PowerPoint. And so you can think of this as either an immutable array or an ordered set. So we just created an index here. So here's our states index. So this is the row index for our Pandas data frame. And then I just assign that to a new variable called ind1. So just sort of as again, a sort of nod to something that you want to make sure that you have a good handle on understanding is when I executed this expression, what exactly happened? So under the hood, what exactly happened with Python? Well, what happened was...
Hey, Dr. Smith.
Yeah.
Quick question. So you know how you said you appended, like you added the coloring, like the colors, the state colors to the indexes? Like,
yep.
How did you do that?
So back up here.
Like I'm going through it and I just...
Right here.
Yes.
This is how I did it. So I created an array. I created a series, right? So here's my series color, right? So here's my dictionary: California blue, Texas red, New York blue, Florida purple, Illinois purple, right? So here's my dictionary. Here's where I created a series called color and showed that. Here's the series, and here's where I added it to my Pandas data frame. So states was my data frame, and I just said, there's not an existing column named color, so I just said, hey, create a column named color and assign the values from the color series. And so this expression right here added that to the data frame.
Okay, so the part that's getting me is, how does it go? So how does it denote that is an actual column? Well,
so I have the data frame name. And then I have in brackets the string color. And so that's telling it. So if you go back to my data frame or just Pandas series in general, as we said, one way to think about a series is as this generalized dictionary, right? And so I say, okay, well, population Illinois. Here's Illinois, right? And there's population. And so it read it as a row. But when I look at the column, so when I look at the population or the area, right, then these are column values and they also have an index, okay? And that's what we see right here. So here's my column index, population, and area. And so what I did in this line of code when I added it, I just added one named color. So now when I look at columns, I have population and area as I did before, and I have the new one called color, which is created by this assignment. right? And so if you think about what Pandas did or what Python did when I executed this line of code, it starts over here and says, hey, what is this? Color.value. So it says, hey, what's color? Well, color is a Pandas series. A Pandas series has a values Numpy array, right? The values, there they are right there, okay? So it's going to extract those values, and then it's going to go and say, hey, what state? States is the data frame. It's going to go look up the color column and say, does this exist? And it doesn't, so it's going to create it, and then it's going to assign all of these values into that column. So that's what's happening with this line, with this expression right here. Okay, is that cleared up for you?
So if you assign color instead of colored values, it works too, right?
If I do, well, let's try that. I don't know the answer to that. So let's just call it X color, for example. If I just do something like this.
Yes.
So now I have X color. Yeah, so it works the exact same way because the Pandas will, in this case, I'm doing an assignment to Pandas, and so Pandas will recognize this as a series. And in this particular case, I'm assuming that if the two indices were different, it would give me some kind of an error. So in this case, the indices are the exact same, and so this works. If for whatever reason I had a different index here, so let's say that I had color and I had CAL, the abbreviation, for example, CAL and TX and NY and FL and IL for the index as opposed to the actual color names, I'm guessing when I executed that line of code, it would give me an error saying your indexes don't match. But since my indexes did match, it worked perfectly. Okay. All right, so does that clear up the original question? And then again, the follow-up question about using values versus using the series reference itself? Okay. So back we talked about index objects, and we talked about what indexes are, and so we can treat the index as these array type objects too. So I have the slicing there, and I can slice backwards, and I can use the step. So when I have : 2 in a slice, as you remember, that means take a stride length of 2. So this essentially gives us every other one, right? So if here's my index, California, Texas, New York, Florida, Illinois. If I want every other one, I'm going to skip Texas. I'm going to skip Florida here, and that's what we get. So it behaves exactly like a traditional array. But it's also immutable. So if I try to say, wait a second, I want to change whatever index 1 is, Florida to Alabama, it says, no, I'm sorry, you can't do that because it's the index is immutable. But we can do standard set operations. So I can do, in this case, we did like the intersection of two sets or the union of two sets or the symmetric difference of two sets. So all of these functions or all of this general functionality is available to generic Pandas index objects. Okay, and the reason that's really important and that's really useful is because of the structure of Pandas. That means that I can use all of these functions on the whole Pandas data frame. So I can either use, an intersection or a union or a symmetric difference on the rows of two different data frames or on the columns, right? Because they're manipulated by these index values. And so that's the basic idea of using Pandas, is that I can manipulate the values by using these indices to access the data in however I choose to access the data, right? In the method that I choose to access the data. Okay? Does that make sense?
Yes.
Questions for me on that?
Yes, I have a quick question about the index.
Okay, ask away.
I mean, we for the data frame, we have the row index and also we have the column index. So we can retrieve the row index, but how we can retrieve the column index?
Yeah, if I can defer that question, I'm just about to talk about that. Let me continue a little bit, and then if you still have the question afterwards, come back and ask it, and we'll go over it some more. Okay?
Okay.
Okay, so let's talk about indexers for just a second. And in particular, I want to talk about two, loc and iloc, and then what used to be called ix. And so back in the beginning of class, I talked about deprecation and I said, we're going to come to a feature that in the book, this was a deprecated feature, but now it's totally gone. Well, that feature is IX. So the IX function, if you look in the book, it's still there, and it talks about that it's deprecated, but as you will see in just a second, it's no longer in Pandas. So for a period of time, it was in this category of deprecated, and every time you would use it, you would get a warning. And the book shows that. But in the current version, it's been totally removed, and so you don't get a warning, you just get an error. So bear with me, and we will get to that. So I have this example, and so my example says I'm going to create a series, and my values are A, B, C, D. My index is 1357, okay? And so when we think about indexing, okay, in our examples before, when I used integer indexes, I used just something equivalent to the native Python index, right? So I use 0, 1, 2, 3, integers beginning with 0. Well, this case, I'm not. Okay, so now the question is, okay, well, if I do data 1, what do I get? Okay, because am I looking for the item with index 1, which would be B, right? Because remember, Python is 0 based, so this would be the 0th one, and this is the first one, right? So if I think in terms of native Python, I would expect data 1 to be B. But data 1 is A, because my index is 1. Okay, and so what we're seeing is the difference between the implicit Python index and the explicit series index. Okay, and so when I use data 1, okay, it's giving me, it's using the explicit index that is defined for my series. Okay, when I do slicing, however, it's using the implicit index. Okay, so this one is using the explicit index. This one, it's using the implicit index, right? Because when I look at 1 and 3, I would get A and B, right? Because 1 is A and 3 is B. Well, I'm doing 1 and 3, but I'm not getting A and B, I'm getting B and C. That's because this slice behavior uses the implicit index, which is 0, 1, 2, and 3. And so the implicit slice doesn't use the last element. So you have 1 and 2, which is where B and C come from. Okay? Everyone see that? Hopefully everyone is
No,
suitably.
can you say that one more time?
Sure. So when I define my series, I have an explicit index. My index is 1357. I also have an implicit index, which tells me this is the 0th element, first element, second element, third element. When I do data 1, so just 1 in brackets, it's using that explicit index, right? The explicit index says, hey, 1 maps to A, right? But if I was looking for the implicit 1, it would be B, because this is the 0th element and this is element 1. So in this case, it's using the explicit index. When I do a slice, however, you know, if I'm think about using the explicit index and I want between 1 and 3, I would expect A and B, because here's 1 and here's 3. I would expect A and B. But it's returning B and C. Well, where do B and C come from? That's the implicit index. Because again, this is the 0th, the first, the second, the third. So if I do a slice from 1 to 3, I get element 1, element 2, all the way up to, but not including the last one. So I get B and C, which is exactly what we got here. So when I do an individual element like you see right here, it uses explicit index. When I use the slice, it uses the implicit index.
Okay, so my question, I guess, now is how does it know when you want implicit and explicit? Because I guess this whole time we've been doing explicit.
That's exactly where we're going next.
Okay.
Okay, so obviously this is confusing. I hope this is confusing. Is you say, well, wait a second, I see exactly what you're saying. Right, so there are two issues here. One is understanding what's going on, and then understanding why it's going on, right? And so the important part right now is understanding what specifically is going on. And when I say this one uses the explicit index, this is using the implicit index, you want to make sure you understand that first. So the answer about what to do is this causes confusion is to not access them that way. Right? The answer is to use these functions iloc and loc, okay? And so what happens is if I use loc, I'm saying I want you to always use the explicit index. So if I do that, if I do loc, then I get A, exactly what we expect. And if I use the slice with loc, now I'm getting exactly what I expect, right? So if I do 1, 3, I do 1, 3, right? 1 is A, 3 is B, 1 is A, 3 is B. I got exactly what I expected because I used the loc function. It said use the explicit index. If I, on the other hand, use iloc, it says, okay, use the implicit index. So the implicit index for value 1 is B because this is the 0th one and this is the first one. And so when I use iloc, I get B. Similarly, when I use iloc on the slice, I get the slice that I expect. Okay? So if I don't use loc or iloc, Python internally tries to figure out what you want and tries to give it to you. But that causes confusion unless you know exactly Python's algorithm for making that determination. And so it's far easier just to, if you want to use the implicit index, use iloc. If you want to use the explicit index, use loc. Okay? So now we come to this last one, ix. And so ix, again, if you look in the book, this would work. So if I use data ix, now it doesn't. It says series object has no attribute called ix, right? And if you did this before, you would have seen an error that said warning, or you would see a warning that it's been deprecated. But here's the answer that you're looking for. Exactly the same thing that we saw when we looked at date time. We got a warning saying it's been deprecated, but it's still there. Okay? This case, it's not there anymore, right? So it says it is telling us it's been deprecated, but it doesn't tell us what. It didn't give us the answer because it's been totally removed. Okay. All right. So continuing on this notion of oops, I didn't do that. That when we have non-integer values, so this time I just created one that instead of having 1, 3, 5, 7, I just used alpha. So I have HIJK, ABCD, and if I do my data 1, 3, I can still have loc and I'm sorry, I can still have loc and iloc, right? And so the loc and iloc behavior, when I say it's still similar, it means when I'm using the explicit index, I'm getting that last value. So I'm getting the K value here. Whereas when I'm using the implicit index, I don't. Okay, so the slicing behavior still is different in how it handles the last value, you know, the trailing value in your slice definition, in that if you use an implicit index, it's everything up to but not including that last index. But if you use the explicit, it's everything up to and including that last value. And that's why we see a K here, but we don't see a K here. Okay?
I have a question.
Okay.
If we have indices as strings, so do we really need them to make, to use a log function to make explicit? They cannot be implicit.
They are implicit, right? So I have it strings here, HJK, and I can still use the implicit indexing, which I'm using the implicit indexing right here, right? So I'm using 1, 3. This is the 0 one, this is the first one, this is the second one, third one. So that's where BC comes from, is I'm using an implicit index as opposed to the string index. Are you asking me that why should I use loc if I'm going to use this term?
Mm-hmm.
Yeah, so if I don't use loc here, you're exactly right, that if I just do this, which I guess I didn't do that above, you know, I get the explicit. This goes back to the thing that this works, but for me, and this is a personal choice everyone has to make, is to me it's less confusing to just go ahead and specify I want to use the explicit index, even if the implicit index won't even work, right? So this way when I look at my code, I say, oh, I'm using the explicit index. And when I see iloc, I say, hey, I'm using the implicit index. And so I just kind of think that way when I work with code. But yeah, you're exactly right that if you don't use that, if you don't use loc, it will work perfectly because I am in my slice using that explicit index. And the confusion really comes into play in the top in the one up here where the index, you know, is similar to but not the same as the implicit index. Here, the index is totally different, so there's probably less avenue for confusion.
Okay.
Okay, other questions for me? Okay, so then again, it's data selection in data frame. So I just recreated my data frame. So here's my area, population, color. We recreated, and we've already seen, I can pick columns here. If I just use data area in this case, I'm not sure if we talked about this last time, this dot notation, but in certain cases, my column name is area. Instead of using the bracket quote, area, quote, I can use dot area. This works anytime that you have a alpha column name and that you don't have a reserved word. So I'm not using some Python reserved word. This notation works. If I want to list of columns, then I can specify as my index internally a list. So if I want multiple columns, that's how I would do it. Note also that I can reorder these. So I have population and area here, and I have area and population in my my data frame. But when I did the slice here, then it sequenced those columns. As we saw earlier, I can also add something. So in this case, I'm adding population density rather than adding an existing series. In this case, I'm just using a universal function or a ufunc where I'm saying, okay, take two Numpy arrays and add them together. And so what that's telling me is I want to do that sequential add that we saw the other day. And so now I created a new column called density and so on. And that density is a computed column. Okay? All right, so back to this question of, okay, well, what about rows? And here's where we're going to talk a little bit about that. So I can use iloc to do slicing using implicit index. So 1, 2 would say that I want, this is row 0, this is row 1, this is column 0, column 1, column 2. So location 1, 2 is this guy, red. That's where red came from. I can also do slicing. And so my slicing says I want, I want the 0, 1, and 2, and I want 1 and 2. And so we can slice the rows and columns.
So quick question, Dr. Smith. When you have stuff like this, so California, Texas, New York, Florida, Illinois will be considered your headers, correct? Are those not on a column?
These right here, this is an index.
Okay, because it's the indexes. Okay.
Right, so California, Texas, and all that is an index.
I was thinking back to homework 2 where they were like all headers.
Well, in homework 2, we were doing Numpy arrays. We were using Numpy arrays.
Oh, so it's, okay.
Okay. So again, you can use iloc to get that slice. And if I try slicing, if I try to use loc, again, now I have a non-numeric. So this notion of using loc makes no sense because I'm saying, when I use loc, I'm saying, hey, use the explicit index, but my explicit index doesn't include 1 and 3. So this is why I'm getting this error saying, wait a second, you can't do slicing because you're using it wrong. But I can use the slicing with the index. Okay? Make sense? Questions for me?
I have a question from previous part when you're using dots to call the columns.
Where I'm using what now?
Before you use data. Before.
How far up?
Yeah, data.
Oh, this one. This. Yeah, go ahead.
Does it work if your column has spaces?
I don't believe so. I don't think it'll work if you have spaces. I don't think it'll work if you lead with numbers or something like that. I think it just has to be a word, and it can't be a reserved word in Python.
Oh, okay.
Okay, so again, we have that error. We can do slicing here. Again, when I do slicing this way, when I use the loc to do slicing this way, I get the entire row. So I have Texas and Florida, and I start with Texas and end with Florida. So we have that, the beginning and ending part of the slice it includes, and it is using all of the, it's giving me all of the columns for those corresponding rows. We can also do masking. So if I do data density, for example, data density greater than 100, you can see what's happening here. And my little note to you, again, make sure you really understand what's going on here. It's an expression that's evaluated, right? So this is an expression that's evaluated. And of course, when you have doubt, if you look at this and say, hey, I'm not exactly sure what's going on here, let's grab this guy out, data density greater than 100, and say, well, what does this give me? Right? And this just gives me that mask. You know, it gives me a data mask using the same the same index. And that data mask is just true, false, which corresponding row values this expression holds true for. And so when I apply that mask to my data frame, it has the behavior of saying, go into all of the values that correspond to true and pull those out. And that's how I get New York and Florida.
I have a question.
Okay.
Yes, for the index data dots density, can we use the same thing for NumPy?
Can you use the same thing? Can you use that same dot notation with Numpy as with Pandas?
I thought because I know this is Pandas, but we can also apply Numpy in Pandas. I think because we are addressing index here, that's why we are using dots notation.
Yeah, Numpy arrays don't have an index. So when you talk about a column, you can't name columns and you can't name rows. I mean, so the way to think about Pandas is, you know, if you look at a table, a two-dimensional, you know, I have names for my columns and names for my rows. That's what an index is, right? That's what the two indices are. With Numpy, I don't have those indices, right? I just have, hey, this is row 0 and row 1 and row 2 and row 3. I'm sorry, column 0, column 1, column 2, column 3, and row 0, row 1, row 2. I don't have that notion of names.
Okay.
Okay, now we did have structured data in Pandas support, but we didn't go over any of that because I said we're going to just use Pandas because there's limited use for, at least to me, for what we're going to do in this class, there's limited use to the Numpy functionality of structured data. Okay, other questions for me so far? And so, of course, we can combine these. So if I want to have a more complex, so I want to show everything that has data density greater than 100 and data area less than, what is that, 150,000, you know, then both of those conditions are true. So a highly dense small area, of course, it's New York. I can take my mask and I can then do a column selection. So note that when I did the default mask here, I just got everything. So I got all of the columns that correspond to these conditional. And when I then append my set or my list here, column and density, then I get that same thing, except I just give the columns that I want. Okay? And so again, let's have a look at this. So this is a data frame. Of course, so I did this slice where I applied the Boolean mask. I then filtered out only 2 columns. And so what I end up with when I do this is a data frame. So I said, hey, let's create a name slice. So I've got high density, and so I just named it, right? So I just took the same slice and named it high density. And when you look at high density, there it is, same thing that I saw there. I said, well, let's change it to something. Let's change something to, let's turn New York purple. And then I go back and look at the original value, and we see here New York didn't change. So my note to you here is, the slice is a copy and not a view. What are the rules here, right? Because I took this slice, updated it, but it didn't update the default. And so that would lead one to believe that when I took the slice, I made a copy and not a view. And in previous examples, when we looked at native Python lists and we looked at Numpy, we sometimes created copies and sometimes we created views. And so what you want to have a look at is make sure that you understand the rules, and then I give you those rules about when it does a slice, when it does a view, and when it does a copy.